was a very famous scientist, and along with his student or scholar, you can say, along with his scholar, he performed this experiment. So Rutherford was very rich, so that is why he was able to perform like he was able to perform the radioactive experiments, because these experiments are very expensive. So what he did was, he took a radioactive source in which alpha particles were present, and the size of alpha particles and the charge is similar to that of helium. Helium charge is +2 and mass is 4. So it is similar to that. The alpha particle charge and mass is similar to that of alpha particle. Yeah. Now what happened is, he took this radioactive source. So this is beam of alpha particles. It is passing through this gold foil. This is thin gold foil, and here at the back he put a sheet of zinc sulfide. This pink sheet is actually of zinc sulfide, and where it's mentioned detector, yes, it's one detector which was made of sheet was of zinc sulfide. And through this experiment he found some results, right? Now what he found was, the results which he found was very shocking for him, because he found that most of the alpha particles, like 99.9% of alpha particles, they went through the gold foil undeflected, right? They went through the gold foil undeflected. Only few, 0.1%, they got deflected by small angles, and only 1 in 20,000 they got deflected by this, like nearly 180 degrees. So these were the observations which were made by Rutherford. So that is why he got shocked with his results, and he said that Thomson's theory was actually not correct. Why? Because we know that the alpha particle, right, the charge of alpha particle is positive, and we know that atom is all, and Thomson said that atom is actually a sphere of positive charge. Like how is it possible that alpha particle they were able to pass through the gold foil undeflected? So he said the theory which was given by J.J. Thomson was incorrect, and he gave his own theory, which was observations. Let us study the observation first. See, first observation: most of the alpha particles, they passed through the gold foil undeflected. Can you see? Most of the alpha particles, they were going undeflected. A small fraction, most like 99.9%, they went undeflected, and a small fraction like 0.1%, they got deflected by small angles, and 1 in every 20,000. So this number is also given in NCERT. 1 in every 20,000, a very small fraction of the alpha particle bounced back. Bounced back means they got returned by 180 degrees. So this was the observation which was made by Rutherford, and based on his observations, he said that the Thomson model is not true, because again the same reason, the atom cannot be just a sphere of positive charge. If it would have been a sphere of positive charge, then it is not possible for alpha particles to pass through the atom undeflected. Clear? Now let us study about the conclusions which were made by Rutherford. So these were the observations which he made after performing experiment. And children, please try to understand this, that it's not like that one day he went to the lab and he started performing experiment and he got the following results. No, actually he did multiple experiments, right? He did multiple experiments, and after that he came to this conclusion, right? So on the basis of the experiments which he performed in the lab along with his scholar, then after that then he made these observations, and on the basis of the observations he drew few conclusions, which are, the conclusions are: most of the space in the atom is empty. He said that most of the space in the atom is empty. That is why alpha particle is able to pass through the atom undeflected. So, and most of the space in the atom is hollow or empty. The positive charge resides in a very small space. He says that the positive charge, that is proton, resides in a very small space, and the positive charge, he called that positive charge as nucleus. The positive charge, he called that positive charge as nucleus, right? He said atom, and inside most of the atom it is empty, hollow, and inside that atom there is one positive charge, a sphere of positive charge, which he named as nucleus. The volume occupied by the nucleus is negligibly small as compared to the total volume of atom. Suppose if the total volume of atom is 10 to the power minus 10, total volume of nucleus is 10 to the power minus 15, which is actually, see, lakh times larger. So atom is actually 1 lakh times larger as compared to nucleus. Clear this much? He made this conclusion because, see, he took alpha particle, and I have told you alpha particle is positively charged, and the mass is also mass of alpha particle is very, very high. So he said, yes, most of the alpha particles, they pass undeflected, but few alpha particles, they got deflected, and in very few particles they got deflected by 180 degree. So he said, yes, there is something which is present inside the atom whose mass is actually larger than the mass of the alpha particle. That is why the alpha particle is getting deflected by 180 degree, right? So he named that sphere as nucleus. For example, if somehow what happens is the bombardment of a collision of a cycle and a truck takes place, what happens? Who will get more hurt or more injury? Of course, cycle, because the mass of cycle is very much less as compared to the mass of truck, right? So same is the case of alpha particle and nucleus. The mass of nucleus is very much higher as compared to the mass of alpha. That is why the alpha particles, they got deflected by 180 degree. Though those alpha particles are very few, but yes, it had happened. So that is why Rutherford named it as nucleus. Hope this model is clear to you. In this model, we had discussed about the experiment which was conducted by Rutherford in his lab. Then we had discussed about the observations which he made, and on the basis of the observations which we had made, the conclusions. Clear, bache? Yes? Okay. Now we have, see, now what we have to discuss is next. Let's go to the next. We have, see. Is it clear till this much? Now we have atomic number and mass number. You must have studied about this in your junior classes. Atomic number is denoted by Z and mass number, it is denoted by A. What is atomic number? Atomic number, beta, atomic number is number of protons or number of electrons, right? Atomic number is number of protons or number of electrons. What is mass number? Mass number is basically number of protons plus number of neutrons. Clear, beta? This is number of protons plus number of neutrons, and mass number is, atomic number is number of protons or number of electrons. Clear? Suppose I have an element X, right? If we have an element X, so how do we write? We write, see, if we have an element X, so we write Z here and A here. Z is the atomic number and A is the mass number. Next, we have isotopes and isobars. This also you must have studied, right? What are isotopes? Which have same atomic number, that is same number of electrons and protons. Isobars, which have same, let us discuss examples also. Same mass number. You must be aware about the example. Suppose we have carbon 7, and one of the isotopes of carbon has mass 14. carbon is 6 and nitrogen 7, 14. Right? These, so here mass number is same, but atomic numbers are different. Next we have same atomic number. See, same atomic number, same mass number, but different atomic number. Similarly here, same atomic number but different mass number. Right? For example, we have hydrogen, right? This and this. Deuterium, tritium, hydrogen ion, right? So these are tritium, protium, deuterium, tritium ion, right? Yes, beta. We have carbon 6, 12 isotope, 13 isotope and 14 isotope. Nitrogen 14, 15, right? So these are these, like chlorine 1735, chlorine 1737, right? So these are the isotopes. Clear, Peter? And these are the isobars. Now on the basis of this, let us do one numerical, a very simple numerical. Calculate the number of protons, electrons and neutrons in bromine, and it is given as Br 35 and let me check 80. Yes, 35 and 80. Okay, so basically the value of Z is 35 and that of A is 80. So number of proton and electron will be equal to 35. Yes, because Z is nothing but number of proton and electrons. So proton and electron will be equal to 35. What about, right? And atomic mass number is number of proton plus neutron 80. So number of neutron will be equals to 80 minus number of proton, which is 35. On solving, you will get number of neutrons, that is 5. 4 minus 3 is 1. No, 7 minus 3 is 45. So this is how we have to solve these questions. Clear? Okay. Next we have, now after doing this, we have drawbacks of Rutherford model. Before coming to the drawbacks, I would like to tell you one more thing about Rutherford, which is, let me tell you here one more good point of Rutherford. See what happened, like, because on this point only we'll be able to tell the drawbacks. Now what happened, see, Rutherford said that the electrons, he assumed that the electrons, they revolves in circular orbits around the nucleus. Electrons, he said, electrons revolve in circular orbits around the nucleus. This was told by this, he assumed it, that the electrons revolve around in circular bodies. Actually, what he did was, he took an analogy to our solar system. We know that what happens, this is our sun, and we know that Earth and some planets, they revolve around sun. They revolve 360 around the sun. They do. Yes. So now what happens? So he said, what he said was, he said, now in an atom what happens, because we know that atom is electrically neutral, and remember children, during that era they were not, because in when Rutherford proposed his model, it was around 1840 or 1850s, I think. But neutron, the discovery of neutron actually discovered in 19th century, and that's what gave this theory in 18th century. So what happened was, Bache, he assumed that we have nucleus, yes, and nucleus is positively charged, that is proton. Now he said, just like as our Earth is revolving around the sun, similarly the electrons will also revolve around the protons, because because they want to because you know that because Dalton has said that the atom is electrically neutral. So following his theory, he said that electrons, they revolve around the protons, in a circular manner, right? Now we all know that sun tries to pull earth towards it through gravitational energy, right? Through gravitational force. The sun tries to pull earth using gravitational force. You must have studied about gravitational force in physics, right? But does it happen that does it happen that earth goes that much close to sun? If this was the scenario, do any life, can you imagine any life existing, any life can you imagine anybody is existent on the earth? No, it's not possible. So what happens actually, this gravitational force, right, which tries to apply on the earth, it gets converted into centripetal force. Centripetal force, due to this centripetal force, the earth is able to revolve around the sun. This centripetal force is actually which allows earth to revolve in circular orbits. Clear? Similarly, here what happens in this case, electrons and protons, they are oppositely charged. So the proton applies electrostatic force, right? You will study about this electrostatic force of attraction in class 12th. Whenever two opposite charges they get developed, so there's electrostatic force of attraction. So what happens? Electrostatic force gets converted into centripetal force, due to which it's possible that the electrons they revolve around the protons because they are in circular motion. So he said that due to which Fe, electrostatic force, will be equals to centripetal force. This is what Rutherford assumed. Right, now let's study about the drawbacks of Rutherford, right? Because he said that because Rutherford has said that the Thomson's model is incorrect, so he had to give us a new model. So in his model he said that we have a nucleus, and the electron inside the atom, the electrons, they revolve around the nucleus, and due to opposite charges, electrostatic force of attraction develops, and that force of attraction is actually equal to centripetal force, which allows electrons to keep on revolving around the protons. Clear this much? Next we have drawbacks of Rutherford. Now what happens is, what the first and major drawback of Rutherford was, he could not, I'll tell you why. He couldn't explain the stability of atom. Like he said, yes, we have positively charged protons and negatively charged electrons, right? And that atom is electrically neutral. But in reality, he could not explain the stability of atom. His theory was actually failed. How? I'll explain you. Just give me a minute. He could not explain the stability of atom. What happened was, bache, see, there was a scientist who gave his theory. When he read about the Rutherford theory, then he gave his theory, and he actually told that Rutherford's theory is not correct. Why? Because, see, Maxwell theory, you will study about this when you study about magnetism or electrostatics and magnetism. You will study about Maxwell. He's a very famous scientist. Now he said, yes, we have a proton and we have electrons are continuously revolving, right? Yes, and they are also changing their direction. So he said any accelerated charge particle, it emits energy and lose energy. Any charged particle, yes, if it is revolving continuously, any charged particle, if it's revolving continuously, it emits energy and it loses energy by emitting. So, what happens is, according to Rutherford's model, he said that the electrons are continuously revolving around proton, but he said that if electrons are continuously revolving, means electrons, there is change in velocity, and change in velocity is acceleration, means electrons are actually accelerating. If particle is continuously accelerating. So he said that what happens, the electron is actually, they are losing their energy, and a time will come when this electron, it will actually falls into the proton. This electron, it will actually falls inside the proton, and thus when this will happen, what happens, atom gets destroyed. But is it possible? Tell me. Have you heard? Yes, we all know that electrons, protons, neutrons, they exist. We all are aware about the existence of subparticles, right? So Maxwell said that the theory which was given by, which was explained by Rutherford was incorrect. Why? Because according to Maxwell's theory, he said that after some time the electron atom will get destroyed because electron is continuously revolving, and if electron is continuously revolving, after some time what happens, a time will come, the electron will start emitting energy, right? And at that time what happens, the atom gets destroyed. So he cannot explain the stability of atom, and second is he could not explain one more thing, line spectrum, line or discrete spectrum of atom. See, we will be studying about the line or discrete spectrum of atom, but his theory did not explain, he did not mention even a single word about spectrum of atom. So these were the discoveries of the drawbacks of Rutherford model. He said he could not explain the stability of atom. Number two, he could not explain the line or spectrum, discrete spectrum of hydrogen atom. Now what is spectrum? Okay, I'll tell you. You must have studied about spectrum in your junior classes. What is spectrum? What happens when we pass a light, white light, through a gas? Suppose we have hydrogen gas or helium gas, right? This is gas, H2 gas. And when this white light, it passes through what happens? It passes through a prism. What happens? This white light actually, it forms a band of colors, a band of 7 colors, which is very famously known as Webb-Gure, right? An atom has this property of showing spectrum, but did we study anything? Rutherford did not mention anything about spectrum. So this band of 7 colors is nothing but actually spectrum, and Rutherford has not mentioned anything about the spectrum. Clear, bache? Right? So we will be studying about absorption spectrum and emission spectrum, right? So these, but Rutherford did not say anything about spectrum, right?